Hi friends, I'm Mohan Amaravati from Sri Venkateswar College of Engineering. Today I'm going to explain about the topic name Programming Techniques for Turing Machines, extensions to the basic Turing machine of TOC, Theory of Computation. Introduction to Turing machines. Turing machines are theoretically computing devices that define algorithmic process. They consist of an infinite tape, a head for reading and writing, and set of states. Turing machines serve as a foundational model for understanding computation and algorithmic functions. Basic components of a Turing machine. The tape is divided into cells, each capable of holding a symbol for a finite alphabet. The machine's head can read, write, and move left or right along the tape. The transition function guides the machine's operations based on the current state and tape symbol. Representation of Turing machines. Transition function explained. So the tuple is equal to there are seven statements like finite state of states, and it's a input states are a tape alphabet where summation is the input alphabet, and transition is said to be a function where left shift to the right shift from taking the finite state of states, and finite set of states. Q naught is the initial state, and B is a blank symbol or blank input, or F is a final state, which represent the seven tuples in a Turing machine. Transition function explained. The transition function determines the next state and actions of a Turing machine. It is usually represented as a set of rules in the format of current state, tape symbol, next state, tape symbol, or direction. Understanding this function is essential for programming Turing machines effectively. State diagram representation. State diagram visualize the states and transitions of a Turing machine. They help in designing and debugging Turing machine algorithms. Each step and each state transition can be analyzed for clarity and correctness. Initial state is said to be a desired to temperature where it will be becoming attempt and cooling the final state and activating heating and activate which belongs in the turn on while ready on a action nested state, and transition is to be a initial state. Programming techniques overview. Structured program. Use of structured program. Easy detection of an error, fix it on location and correct it. And third one is this saves a lot of time. First one is it enables the programmer to understand the program easily. Structured programming and programming techniques overview. Programming Turing machines requires a structured approach to algorithm design. Techniques include state minimization, modular design, and systematic testing. Effective programming can simplify the complexity of the task assigned to the Turing machine. State minimization technique. State minimization reduces the number of states in a Turing machine while preserving the functionality. This technique enhances efficiency and simplifies the transition function. Minimizing the states can significantly decrease the computational overhead in processing. So this is the inputs where we can get the present outputs before a present state can be inputted in the next state and output. So state minimization and symbolic state table. Minimizing number of states, reuse states where possible, and symbolic state transition table. Modular design approach. Modular design involves breaking down complex computations into smaller, manageable models. Each model can be designed and tested individually before integration into the larger system. This approach fosters reusability and clarity in the programming of Turing machine. Main program says to be function and function B or function C taking any functions, and that will connect to model. So that is a mainframe of a main program. Systematic testing methodologies. Systematic testing ensures that each transition and state behaves as intended. Test cases should cover normal, edge, and error conditions for thorough validation. Effective testing identifies issues early in the development process, saving time and resource. What state transition testing? So this is the state transition testing while in a systematic way. Extensions to be basic Turing machines allow Turing machines which perform a more complex computations. Common extensions include multi-tape Turing machines and the non-deterministic Turing machines. These extensions enhanced the computational power and flexibility of the original model. Multi-tape Turing machines. Head is the main function where can be element fixed in a one by one. Multi-tape Turing machines have multiple tapes and heads each operating independently. This structure allows for more efficient algorithms as multiple data can be processed simultaneously. Multi-tape machines can simulate single-tape machines, demonstrating their computational equivalence. Non-deterministic Turing machines. Non-deterministic Turing machines can have multiple possible actions from a given state. This model allows for parallel algorithm exploration of computation paths, increasing efficiency for certain problems. Although they offer theoretically advantages, practical implementations remains challenge. Accepting and rejecting in a non-deterministic, it will base on the axis of f to the n number of functions. Turing machine varianties. Variants of Turing machine include alternating probabilistic and quantum Turing machines. Each variant introduces unique computational paradigms that expand the theory of computation. Understanding these variants helps in grasping advanced concepts in computer science. Practical applications of Turing machine. Turing machines are not just theoretically but have practical implications in algorithm design. They are used to study computational complexity and disability in various domains. Many modern computing concepts stem from principles established by Turing machines, complexity classes, and Turing machines. And it will reduce the number of it will reduce the number of states to simplify the machine while preserving functionality. Composite tasks using sovereignties smaller break down tasks into smaller sovereignties like copying, shifting, comparing to manage complexity. Markers use symbol or marks on the tape to remember positions or indicate phases of computation. Multiple tracks use multiple virtual tapes on a single tape by dividing the tape into tracks, enabling parallel processing of information. Iterative and recursive process, implementing loops for repeated tasks or recursion for complex nested computations. Two-way scanning, move to tape at both left and right to perform multipass algorithms. Use urinary or binary encoding on the tape to perform counting-based operations. Extensions to the basic Turing machine, multi-tap Turing machine, multi-track Turing machine, non-deterministic Turing machine, universal Turing machine, probabilistic Turing machine, quantum Turing machine, oracle Turing machine, and alternative Turing machines, where last one is a linear bounded automation. First one is multi-tape Turing machine. Multi-tapes each with its own head to increase computational efficiency. Single tape with multi-tape tracks for parallel storage and processing. Non-deterministic Turing machine allows branching computation paths, accepts input if any path reaches the accepting state. Universal Turing machine, a TM capable of simulating any other TM by encoding its description and input on its tape. Probabilistic Turing machine introduces randomness by transition and extends the classical TM to operate with the quantum states and superposition of a quantum Turing machine. Oracle Turing machine incorporate of an oracle to solve specific problems instantly, representing higher computational power. Alternating Turing machine combines features of NDTM and non-deterministic Turing machine and deterministic Turing machine with alternating extensional and universal states. Linear bounded automaton. A Turing machine with a restricted tape length proportional to the input size used for context sensitive language. So, in alternating Turing machine, alternating between essential and universal states for any other Turing machines are like reducing the number of states in the Turing machine, simplifying construction, program the technique of Turing machine, composing the tasks using substituents and markers of special symbols are used as markers to help the Turing machine remember certain tape positions. Marketing the start of a sequence for reference using a symbol to indicate that the task has been completed. The single tape is conceptually divided into multiple tracks. Each track can hold the separate information. Iterative and recursive and complexity classes the Turing machines. Complexity classes categorize problems based on their computational resource requirements. Turing machines provide a framework for defining classes like P, NP, and P space. Understanding these classes is crucial in fields such as cryptography and algorithm research. Limitations of Turing machine. Turing machines cannot solve every problem, as evidenced by the halting problem. Some problems are undecidable, meaning there is no algorithmic solution. Recognition these limitations is vital for understanding the scope of computability. Turing machine simulators. Simulators allow for interactive experimentation with Turing machines. They provide visible representation of the tape head movement and state transitions. Using simulators can enhance understanding and facilitate learning about the Turing machine. Future directions in Turing machine research. Ongoing research explores the implications of Turing machine in quantum computing, investigating the limits of computational continues to inspire new theories and models. The evolution of Turing machine concepts drives advancements in computer science and technology. Summary of a key concept. Turing machines are foundational to the study of computation and algorithm design. Programming techniques and extensions enhance the capabilities of traditional Turing machines. Understanding these concepts is essential for anyone pursuing a career in computer science. So, questions and discussion about the Turing machine. This is about the theory of computation, which comes under the TOC. Thank you, guys.